How's everybody feeling? Good, good. Okay, so I'm Mathieu, founder at Linera, and I guess for today I'm also CSO, chief scientist, I guess. I don't know. Because the temperature is perfect for an app right now, and I'm myself completely liquefied, I'm going to make way more controversial statements than usual and try to get people angry. So just a disclaimer, okay? Have had some success with that in the past, so I'm gonna try again. So today I'm very excited to speak about some of the core ideas behind Linera. Yes? Yeah, here we go. And so I guess we're here because we like the idea of building amazing products based on blockchain technologies. And so I think it's fair to say that for a while people have been worried about infrastructure, and we're starting to feel better about infrastructure in Web3. In particular, we're starting to have those very high TPS chains, like the new generation that has like very impressive TPS and even like very fast block latency. So you might think like, okay, are we done now? Like, is this good enough? Like, can we now go and go after consumer adoption and yeah, make it happen, okay? And so in this talk, so I'm gonna say not so fast maybe, because so this is the typical typical diagram, like the schema of high TPS chain. So you have the layer one, so some validators, maybe some kind of mempool, and they're going to essentially receive a query. I mean, then you're going to have some full nodes in the system that are replicating the data and providing services to the end users that have a browser and a wallet. And so these RPC providers, they have a lot of work to do. They are mediating everything, basically. They have to serve queries, and then they have also to potentially post into the mempool the transaction from the users. And so what's happening here is that when you have a blockchain with this traditional diagram, so I didn't represent it, but so you imagine you have a single chain. To get the kind of TPS that we want, you're going to have to use very large blocks. That's nice, you're fast, but there's still a limit in the TPS. So now I come from a background of Web2. I was a software engineer at Facebook before joining the blockchain project of Facebook. And where I come from, when there's a limit in the TPS, it means it's not scalable. So that's my first controversial statement. So people are saying, oh, that's it, we're scalable. But no. If you have a limit in the TPS, in the kind of Web2 industry I come from, you're not scalable. Like, they're going to laugh at you. They're not going to take it seriously. First thing. Okay. So another problem also, when you have a single chain and you have a set of validators, you got to put them somewhere. So if you put them in one region of the globe, then people in that region are going to have a very good latency when they submit the transactions or when they interact with the chain. And everybody else in the world is going to suffer from like the global, essentially, latency of the internet. If you put the validators everywhere, then it's kind of like average for everybody. So there's this dilemma here about how you manage this cross-region connectivity, how you go faster than the worst-case scenario in the internet, I guess. And of course it does matter if you're looking at large-scale use cases like DeepIn, social networks. You do want to scale out. You're trying to compete with Twitter, YouTube. You want millions of active users interacting with the system. So yes, scale is going to matter. The second thing is that to achieve high TPS in traditional, in these modern chains, like I said, you're going to have to use large blocks. And the other thing you're going to have to do is to separate the consensus from the execution of the blocks. So there are different names, but I call it deferred execution. And that in itself is fine for a single chain of blocks, but it's also, you got to be aware that it's going to create some data latency down the road for the RPC providers, because now they have a very high stream of transactions coming their way, and they have to execute them, and it's going to take a bit of time before they can actually serve data, useful data, to the browsers of the users. So you're introducing data latency, which is not ideal if you're creating gaming systems, for instance, because you would like, it's not if you interact with the chain and the chain tells you your transaction is in a block, congratulations, it's not enough. You also want the other users to see the result of your transaction because you're playing a game with them. You maybe just transferred, maybe it's a payment system. You want that to be instantaneous, so you want the other users to see what you're doing. And so also this deferred execution is bad for, is restricting the kind of transactions you can execute. The transactions are going to be strictly deterministic. If anything has the slightest chance to be non-deterministic, it's really not going to work. And you know, if you are building a system where you'd like to interact with the external world, that's actually a problem. If you want to query AI oracles, they could be, okay, at times, there could be some rounding errors. If you interact with data services, so you may want to download data, and at times they're not available for some of the validators. So that's another limitation. And last, we've built these magnificent security systems with a lot of replication, to some extent military-grade security. But then when it comes to displaying data to the user, we are not authenticating anything. The users are going to have to trust their RPC providers, take the data for face value, unless they're using obscure light clients or ZK proofs that are going to add latency, and so would cause other problems down the line. So, and that's a problem for automated trading. So if you want to make automated decisions based on the data that are saved by RPC providers, maybe that's not super wise to take those data as face value. Another thing also, like I said, so if you're trying to use blockchains to build security applications, maybe you want to establish secure channels, you want to relay on-chain identities into the world, well, you want the data to be run in a secure way. So that was the long introduction to Linera. What we're doing, Linera, we built a layer 1 with the new concept called microchains, which is essentially the opposite of a single chain with large blocks. We're doing many small chains with small blocks, and we run them in parallel in a single set of validators that we are going to build to be elastic. And all the chains, they have the same level of security, the same apps, and because they are small, we can synchronize them everywhere, including on the client side in real time, solving some of the security problems that I was mentioning. This is a generalization of a research paper I made at Facebook that was called FastPay. We added smart contracts and a bunch of other things. And one thing also that I should point out is that in this system, clients are very active. In particular, they propose blocks, and we are able to give them their own chain of blocks. To give you a quick overview why that's interesting, how do you use that to create fully scalable applications? I chose this example of an airdrop. So imagine you want to do a ZK airdrop at scale, like internet scale. So let's say you're going to have an app chain, so a small chain that is the one delivering the coins. And that's going to be a bottleneck, and you'd like to really reduce the amount of work that this app chain has to do. So what we're going to do is that we're going to use the chains that are brought by the users to verify the expensive part, to verify the ZK proofs. So now, as a user, in Linera, I have my own chain. I'm going to submit this ZK proof in my own chain. And then there's a secure message that goes from my chain to the app chain that says, hey, this user has a valid ZK proof. Now you can send back the coins. And when you do that, you do the expensive operation on the chain of the users, and every user has their own chain. So you get this horizontal scaling. Another thing that was also very cool, if you want to power chess games or any kind of on-chain games, in Linera, we would spin a chain just for one game instance. So now you can have as many games in parallel. The system knows how to handle them. So you have one block per move, and the two users are playing the move in turn. It is completely horizontally scalable. And finally, to give you, to finish on the security aspects, why are we end-to-end secure? We are end-to-end secure because the chain of blocks that the users care about are replicated on the client side. So we actually run a VM and we execute the state of the applications. And our browser extension acts as a trusted local RPC providers for the web UIs. And so our system doesn't need any trusted third parties because the browser extension is the RPC provider. And that's it.